Question number 7. This question is from numerical solution of equation. The diagram shows the curve y is equal to x e power 2x minus 5x. This is the equation of the curve and its minimum point m where x is equal to alpha. This is the minimum point. M is the minimum point on the curve where x is equal to alpha. Show that alpha satisfies the equation alpha is equal to 1 over 2 log 5 over 1 over 1 plus 2 alpha. Show that alpha satisfies the equation alpha is equal to 1 over 2 log 5 over 1 plus 2 alpha. This is the minimum point m. For minimum point, the value of the gradient will be 0. Gradient at minimum point will be 0 because the tangent is becomes parallel to x-axis. So gradient will be 0. So first we will differentiate this equation of the curve, find the gradient, and then we will put equal to 0. Y is equal to x e power 2x minus 5x. This is the equation of the curve. Differentiating with respect to x. In the first term, we will apply the product rule x and derivative of e power 2x is 2e2x plus e2x and derivative of x is 1. This is the differentiation of the first term, product rule, and the differentiation of minus 5x is minus 5. 2x e power 2x plus e power 2x minus 5. For minimum point, dy over dx is equal to 0, so we can equate to 0. From here, we will make x the subject. X is the x coordinate of point M, which is represented by alpha. So we can write it 2x e power 2x plus e power 2x is equal to 5. Taking e power 2x as a common, 2x plus 1 is equal to 5. E power 2x is equal to 5 over 2x plus 1. Taking log each side, log e power 2x is equal to log 5 over 2x plus 1. Due to log properties, this 2x, which is the power of e, comes down here before the log. It becomes 2x log e is equal to log 5 over 2x plus 1. Here log e is equal to 1. Log e is equal to 1, so we get 2x is equal to log 5 over 2x plus 1. Now from here we can find x x is equal to 1 over 2 log 5 over 2x plus 1. Since the value of x for this minimum point is represented by alpha, so we can write it in place of alpha we will put in place of x we will put alpha. So alpha is equal to 1 over 2 log 5 over 2 alpha plus 1 और यही हमने शो करना था. Alpha is equal to 1 over 2 log 5 over 1 plus 2 lambda. Now move to the next part of this question. Verify by calculation that alpha lies between 0.4 and 0.5. We have to show that alpha lies between 0.4 and 0.5. Here we will use sign change rule. First of all, we will make a single function of this. Alpha is equal to 1 over 2 log 5 over 1 plus 2 lambda, 2 alpha. Now we can write it as alpha minus 1 over 2 log 5 over 1 plus 2 alpha. Now this is a single function is equal to 0. But we don't need an equation. We will represent it by a function fx f alpha because the variable used here is alpha. We will represent it by f alpha, function of alpha. Now root lies, we have to show that root lies between 0.4 and 0.5. In place of alpha, first we will put 0.4. For this part of this question, we will set the calculator mode on radian. Alpha is equal to 0.4 minus 1 over 2 log 5 over 1 plus 2 into 0.4. Now after calculating we will get this is equal to minus 0.111, and similarly we will find f 0.5, that will be 0.5 minus 1 over 2 log 5 over 1 plus 2 into 0.5. After calculating we will get 0.0419. Clearly these signs are opposite. F0 is negative and F0.5 is positive. This shows that alpha lies between 0.4 and 0.5 because it follows the sign change rule. F0.4 is negative and F0.5 is positive, hence verified. Next part C of this question is use an iterative formula based on equation in part A to determine alpha correct to 2 decimal places. Give the result of each iteration to 4 decimal places. First of all, iterative formula based on the equation in part A. This is part A. From here, we can make the iterative formula. On the left hand side, which is alpha, we will write here n plus 1. On the right hand side, we will write alpha n. So this will become iterative formula. Iterative formula is alpha n plus 1 is equal to 1 over 2 log 5 over 1 plus 2 alpha n. This is iterative formula. Now with the help of this iterative formula, we will find different iterations correct to 4 decimal places. Starting value of alpha, since the alpha lies, because starting value is not given, we will uh, take a suitable value between 0 0.4 and 0 0.5, because alpha lies between 0 0.4 and 0 0.5. So we are taking a suitable value between these two values. We can take mean of these two values. So that will be the first iteration, which is equal to alpha 1. That is the mean of 0 0.4 and 0 0.5. That is 0.45. This is the first iteration. Now we will find alpha 2. We will put in place of an 1. So we can find alpha 2. Alpha 2 in place of n. We are putting 1. 1 over 2 log 5 over 1 plus 2 alpha 1. अल्फा 1 की वैल्यू हमारे पास 0.45 है, तो पुट इन हियर 0.45. we get alpha 2 is equal to 1 over 2 log 5 over 1 plus 2 into 0.45. After calculating, we will get 0.4838. इसको कैलकुलेट करेंगे तो we will get this iteration correct to 4 decimal places, that is 0.4838. This is the second iteration. Now we will find alpha 3. 1 over 2 log 5 over 1 plus 2 into alpha 2. Alpha 2 is this 0.4838. 0.4838. After calculation, we get 0.4663. Now next is alpha 4. 1 over 2 log 5 over 1 plus 2 into the value of alpha 3, which is 0.4663. 0.4663. We get 0.4753. Next is alpha 5. 1 over 2 log 5 over 1 plus 2 into alpha 4. Alpha 4 is 0.4753. We get 0.4707. अभी तक ये डिफरेंट आइट्रेशन हैं. यहाँ पे देखें, ये करेक्ट टू 2 decimal places, आंसर सेम नहीं आ रहा, तो कन्वर्जिंग जो है वो नहीं हो रही. तो हमने फाइंड करना है करेक्ट टू 2 decimal places. तो करेक्ट टू 2 decimal places अभी आंसर डिफरेंट आ रहे हैं. एक हमें और आइट्रेशन फाइंड करनी पड़ेगी, दैट इज अल्फा 6, 1/2 log 5/1 plus 2 into alpha 5, that is 0.4707, 0.4707, we get it 0.4730. Now clearly in alpha 5 iteration is 0.4707, correct to two decimal place, इसका आंसर अल्फा 5 का भी 0.7 है, अल्फा 6 का भी correct टू डेसिमल प्लेसेस, आंसर जो है वो 0.47 है. So this shows that the value of alpha is equal to, correct to two decimal places, 0.47. This is the answer.